Hi, welcome to question 9 of the Leaving Cert Ordinary Level Paper 1 for 2025. So we got stuck in, we're looking here at a tax question. So as always, pause the video, give it a go yourself, see how far you get, and I'll go ahead and read the question. So Evan has €4,500 saved. He put this money in a savings account with a rate of 2.8% per annum compound interest. Now, compound interest, if you're doing more than 1 year, you add on the interest earned to the principal. So you earn more the following year and it builds. It's the power of compound interest. Whereas simple interest is just the same amount you get every year, even though the money is growing. Now, part one says, find how much money will be in the account after 1 year. Now, this is fairly straightforward in a way. You could use the formula, okay? I'm going to do it piecemeal here, but in the next question, we're going to use the formula so we get to practice both. Now, the first thing I do is kind of put it into like an equation. So the money saved is equal to the 4,500 you originally had plus 2.8% of 4,500. Now, you can use the percent button on the calculator or just multiply by 0.028 because at the end of the day, 2.8% is 2.8 over 100. So this is not, the number is not as straightforward. But we're multiplying that and we end up then getting this number, 126. I'm going to add them together to get the final answer of €4,626. And that's what he has in his account at the end of that first year. Now, part two says, hence or otherwise, because you could just keep going, okay, find how much money will be in the account at the end of 3 years using the rate of 2.8% per annum compound interest. So the percent hasn't changed. You could just get 2.6% of this new number and add it on, and then get 2.8% of that answer and add it on and be done. Now the final thing says, give your answer corrected near cent. But let's get an answer first. So this is the formula. Okay, it's in the maths tables. The F means the final amount, okay, your answer. The P is the principal, your starting amount, so the 4,500. The R is the percentage rate, which is 2.8%, okay. And then the N is the number of years, which in this case is 3 years. So if we put those numbers in, okay, we're looking for the final amount. That's our unknown. We know everything else, so this will work. It's just a matter of doing it. The principal is the 4,500, the 2.8 over 100, okay, and then to the power of 3, okay. So we go through the calculator then, and I got an answer of 4,888.76, which makes sense. And always try to put these tax questions through, your truth meter, for lack of a better word. Does that number make sense? Like, it's not going to be massively bigger, but it is bigger. 2.8% is not a huge amount, but it's not nothing. So it's not ringing any bells or alarm warnings for me. So I'm happy enough to move on. Now, part B, patterns are easy for some, less easy for others. This one I found tricky enough because of so many words. So be careful reading it. If you have to read it 3 or 4 times, don't be embarrassed. I have to read it 5 or 6. Now, a pattern is made up of dots and line segments. So I see in pattern 1, there's 2 dots and 1 line joining them. Pattern 2, there's 3 dots, 1 more, and that means there's 3 lines drawing. And then they give me pattern 4, which has 5 dots, and then a whole pile of lines go between. Okay. Now the dots are evenly spaced on a circle. Each pair of dots is joined by a line segment. The first pattern has 2 dots and a line segment joining them. Each pattern has 1 more dot than the previous pattern. The diagram below shows pattern 1, 2, and 4 in the sequence. We are asked in part 1 to do the dots for pattern 3 are drawn below. Complete pattern 3. Okay, so this wasn't actually, that was already on the exam paper. I just forgot to put it in. Now here's the answer. Okay, so if there's 3 dots and they have to be evenly spaced, and that's what gave me a bit of a pause when I first did this, not reading the question properly. But if there's 4 dots and they have to be evenly spaced, it's going to form a square. And you have to kind of realize that. Okay, and again, that's not as easy for every brain type as it might seem for some. So you draw the 4 dots on it. They have to be evenly spaced out. It's the only way they could go. And somebody could do the dots like that or something. It doesn't really matter the orientation of the square. And then you're just joining all the lines together, including the lines in the middle. Okay, and that's the answer for part 1. Now, part 2 says complete the table below to show the number of dots and line segments in the first 5 patterns of the sequence. The number of line segments in each pattern is in a quadratic sequence. And they give us some answers. So the first one has 2 dots, 1 line join them. The second one, if you look back at the diagram, okay, has 3 dots and 3 lines. Okay, so 3 dots, 3 line segments. Now the third pattern has 4 dots. We drew that. Even if your answer here was wrong, but it was correct based on your diagram, you'll still get the attempt for that little bit. So it's 4 dots and 6 line segments. Pattern 5 has 5 dots, and this was given to us already, 10 line segments. We count them up. And then the next one has 6 dots, okay, and 15 patterns, 15 line segments. There is a pattern in the pattern. If you see it here, the difference between these is 2. The difference between 6 and 3 is 3. The difference between 10 and 6 is 4. The difference between this next one, if it follows that same pattern, would be 4 plus 1. So it's going up by 1 every time. This is 2, 3, 4, 5. Okay, and that little leap of cognition there is going to be useful later on. Now, part 3 says write down the number of dots in the 1000 pattern. Now, pattern 1 has 2 dots, pattern 2 has 3 dots, pattern 3 has 4 dots, pattern 4 has 5 dots. Okay. As the pattern increases, the number of dots increases by 1 every time. So if the 1000 pattern, okay, is 1 extra, the number of dots, the answer should be 1000 plus 1, 1001. That's it. Okay, again, that one gave me a bit of pause as well. I didn't really know what they were asking. I was trying to see, was there a formula for it? But it was just actually much easier than you'd expect if you catch it. And that's always the issue. Do you catch it? Okay. Even writing down what the pattern is for the first few would hopefully have gotten something in terms of like a low partial. Now, part 4 says S of n is the total number of dots required to make the first n patterns, where n is an element of n. So that means that your n is a natural number, positive whole number. Then it says write S of n in terms of n. Now, the great thing about this is there is a formula in the maths tables, okay, and it's this formula here. Okay, it's in financial maths. No, it's sequence and series. Now, this has a number of things going on. The a value is the first term. In this case, it's 2. The difference is 1. Okay, so the difference is given back in the previous question. Now we fill them into the formula. Instead of the a value, I'm going to put the 2. Instead of the d, I'm going to put the 1. Now there's still 2 unknowns, so I can't solve this, but I can make it simpler by multiplying out brackets. Okay, so the 2 times 2 is just 4, and then multiplying the 1 by both terms. 1 by n is just n. 1 by negative 1 is negative 1. I can do a little bit more tidying up. Okay, add the 4 and the negative 1, and I get 3. This is a way of describing the total number of dots for any pattern. So we're talking in generality. Now, part 5 says, hence or otherwise, find the total number of complete patterns in the sequence that can be made using 740 dots. Okay. Now, in this case, we're given what S of n is, not n. So it's a little bit less straightforward than we might like it. When I put the 740 in, I'm putting it in here. So the n's are kind of trapped. Now, we can fall back on algebra. If you're trying to resolve or simplify an equation, you see brackets, multiply them, okay? Actually, before I do that, I'm going to get rid of this 2 just for simplicity. The 2 here is divided on the right. So I'm going to move it over here just so I'm not worried about a fraction here. It'll become multiplied on the far side. Okay. That gives me an answer then of 1480. And on the right hand side, I'm going to multiply out the brackets. N times n is n squared. N times 3 is 3n. Now, that's a quadratic. I know that because the biggest power is 2. Okay. I just have to solve it. Okay. Now, if you see a quadratic, you should always solve it. Now, I'm putting it in the format they generally like it. It might look more familiar. I've just brought the 1480 across. It was positive on the left. It'll be negative on the right. Okay. And I have my kind of classic quadratic expression, or equation in this case. Now, we could use the quadratic formula. Okay, that takes a lot of editing and stuff, and that's perfectly fine. And in the quadratic formula, it's given in the maths tables, you need to know the a, b, and c value, and the a is the number in front of, in this case, the n squared, so it's 1. The b value is the number in front of the n, so in this case, it's plus 3. And the c value is the minus 1480. A lot of times people just, they ignore the sign and just take the number. But you have to put in the negative. And you get the answer. I'm doing it using the kind of faster method, okay? And I'm looking for 2 numbers that multiply to give negative 1480 that also add to give plus 3. And I write those numbers down here, and I just have to think it through. Now I need to know the value of the factors, okay? So I take both equations, I can separate them out and put n minus 37 equal to 0. Now that's the same thing as n equal to 37. Or my answer could be n plus 40 equals 0. Bring the 40 across the equal, if you can imagine it, and I get negative 40. Now, only one answer is right, but they tell me in the question that my n value must be a positive whole number. So the only answer that makes sense is 37. That's the answer. So a tricky question, in a way, not as straightforward in that we had to kind of move things around a bit more. But this kind of question, you'll often end up with a quadratic. And if you're struggling with this faster method, just use the quadratic formula. It takes a little bit more time, but it'll be more reliably correct. Now, part 6 here, says the formula for the number of line segments in term n is of the form. Then they give me this function, t of n is equal to 0.5 times n to be squared plus b times n. It says find the value of b, where b is an element of q, and that means it's going to be in a fractional number. Okay. Now, what's going on there? So I'm rewriting my function. Okay. Now, I know some information here. I know that when n is equal to 1, t of n is equal to 1. Okay. I'm going to put those numbers in. Like I could have used n is equal to 2, t of n is equal to 3. Okay. But just the 1 seems easier. Okay. You can use any pattern. Now, when I substitute the numbers in, so instead of the t of n, I put 1. Instead of the n, I put 1 in, but it's in 2 places. Now, if you look at it, this is an equation of one unknown, so this is solvable. Okay, I can go ahead and remove the brackets by multiplication. So 1 squared is 1 times 0.5 is itself, and 1 times b is b. Now, to resolve this, I need to get rid of the 0.5, so I'm going to take away 0.5 on the right-hand side. If I do something to one side, I have to do it to everything on the far side, so I'm going to take away 0.05 on the left. Now, there's a few little calculations I have to do there. Okay, 1 take away 0.5 is 0.5, and then these 0.5s have cancelled out. So my answer is 0.5, and that's it. Now, the trick with this question was realizing what you had to relate. Okay, so as long as you have the pattern and the number of line segments, so this is n is equal to 1, so t of n is 1. This is n is equal to 2, t of n is equal to 3. And in fairness, if you put any numbers in, as long as something of them is correct and resolved it out, you might get a wrong answer, but you'd probably get a fairly decent grade in that question. Right, so that's the end of question 9. As always, if you want a copy of these notes, just send me an email at shanetroy@gmail.com. Like and subscribe to get access to more playlists. Best of luck.